Hello everyone. Today's discussion of this video, the topic is difference between proportionality and equality. Now you might be wondering that why I came upon with such a subject which is proportionality and equality. Well, in mathematics as well as in physics, we come across those two concepts almost on a regular basis, which is either proportionality or equality. Now, we have seen with the equations of Newton and otherwise that when we say that force equals to mass times acceleration, what we are trying to tell is that there is a constant which is a k. Now, there is, once we remove the constant that is k, the equation becomes F equals to ma. But there is a certain underlying concept which looks more or less similar. So when we say proportional, do we mean equal? And how do we remove the equality, the constant sign in order to get the equality? So I would be discussing a little bit more on the difference and what are the essential aspects of proportionality and equality, which are more or less similar concepts, but yes, there is a subtle difference. Now, in order to go ahead with the concept, what I thought is that this is a basic definition in mathematics. What is a proportionality and quantity? Now, if you look into the definition, it is written that in mathematics, two quantities are said to be proportional if they vary in such a way that one of the quantities is a constant multiple of the other, or equivalently if they have a constant ratio, right? So there is a certain change in terms of these quantities, and when the one quantity varies and so does the other one. But as you see, equality means they are the same. So from the definition, it becomes clear that proportionality means that they vary in such a way that one of the quantities is a constant multiple of the other. And equal means that they are exactly the same. So now if I take away this definition and if I would cite a kind of a similar example, so what we can tell from this particular definition, what we have just read, that if I take a variable, say x, right, and so what I would like to say is that say for example, if x increases in this part, say if x goes up by twice, and if there is another variable which is y, right, so y would also increase twice. Right? So x increases and y increases. So I can also tell that if x equals to 3x, right, then y will also be equal to 3y. Something like that. So this is something which is proportional to each other. So proportionality is denoting that once x increases by 2 units, y also increases by 2 units. X increases by 3x, y increases by 3y. Right. So what I am trying to tell is that this is direct proportionality. That is, say for example, A, which is directly proportional to B. So what is happening is that if A is increasing by a certain amount, B is also increasing by a certain amount. Now, if I take the concept of inverse proportionality, so I can tell that A is inversely proportional to B, right, in this way. So in the same way, so now from this, if I deduce a value, say for example, I tell here A equals to B, right, A equals to B. That means that the values are exactly the same. Whatever the value which S has got, it can have X, Y, it can have n number of values. It would be exactly equal to the number of values X, Y, dot, dot, dot. So now you see that the basic difference between these two is that when two values A equals to B and A is proportional to B, that means that whatever A happens, it increases, it goes down, whatever it happens, B also does in the same way. So proportionality actually means that there is a certain change, right? If they vary in such a way, the other quantities is constantly varying. Whereas A and B is similar means that the values are exactly the same. Taking a further example, I can take, say for example, if I say for example E, which is directly proportional to F, and F would be directly proportional to E. That means there is some change in A which is resulting to F, and some change in F which is resulting to E. We are not coming why we are removing the proportionality sign. This is just to give you an example. So when the different items are related to each other in such a way, when the quantity of one changes in such a way that the quantity of the another changes, there will be corresponding change in the quantity of the other. Now, say for example, we take a kind of a similar case, but here what I would like to tell you is that say for example, if this one, the inverse proportionality, so it shows that if B increases, A would decrease. This is the inverse proportionality. Okay. Now, say for example, let us take one example which will further make clear. This example would be something which will tell you that why do we put a constant sign. So from Newton's equation, what we got is if F equals to ma, which is very common. So we knew that if it was F equals to K times M times A, right? F was proportional to K times M times A. And we removed this and we made it F equals to ma, right? So if we do a similar kind of an example, first of all, we will understand now that why we are introducing this constant, and why do we introduce this type of constant. When we remove this constant, it shows the constant to be 1 or something like that. So this was the concept. So say for example, there is a factory. So let us take a fresh example. So I take a factory. This is just to give you a kind of a visual representation. This is a factory. Okay, and what we are doing is that we are measuring the production with the output. So if, for example, I take the production of glass, that is G, is directly proportional to the output of glass, that is G, right? So the production is directly proportional to the output. Now if I take, for example, something like this, where what I would do is that when we are producing 20 units, the output is 10 units. Say for example, the production of glass. When it is 40, it is directly proportional to 20. When it is 80, it is directly proportional to 40. When it is 160, it is directly proportional to 80. Right. So you see there is a constant, change from 10 to 20 to 20 to 40, 40 to 80. Right. So what it is happening? Now say for example, what we are going to do is that we want to remove this proportionality sign. So for example, here I would write those units, say 20, 40, 80, 160. Let me put a different color so that things will be clearer to you. So this is 20, 40, 80 and 60. And what I'm going to do is that I'm going to remove the proportionality sign, and I'm going to put here 20, is it equal to 10? No, it is not. 40, is it equal to 20? No, it is not. 80, is it equal to 40? No, it is not. 160 is proportional to 80? No, it is not. Right. So what we are going to do is that we can put out a constant, that is 2. As you see, each time we are multiplying it by 2, we are getting the same output, right? So from here, what I can tell is this, that the production, say for example, if I write it in this convention, production of glass, right, is equal to the output of glass times some kind of a constant, which is a K. This is a constant which is a K, right? So now you see that the production of the glass, if I want to make it equal to the output of glass, every time we have to put this 2. So this is actually that 2 which we are putting, right? So now you see that say for example any kind of this kind of a calculation when we are equating. So you see what is proportionality. With this value, with this value and this value, there is a kind of a change. When it is 20, it is 10, 40, 20, 80, 40, 160, 80. So proportionality is this. So when we are replacing this proportionality in order with a equal to sign, that means we are now equating the two values to be equal. That means the two sides have to be equal. But now, as you understand, it is not proportional. I don't know whether I've been able to clear out the concept, a little bit fuzzy. But when we are putting this equal to sign, we are deliberately putting this k, which is this 2. So that with every 2, the values are now equal, but not proportional. Values are equal means 20 equals to 20. I will show you just another example. Say for example this case, if I take this part, right? When I am saying that 20 is proportional to 10, right? That means 20 and 10 has got a relation. That means if it is going up, it will be going up. But when I am using this term, production of G equals to K, which is a constant of the, say for example, output of G, right? When I'm introducing this K, which is the value 2, so that it is multiplied, mind it that when I'm saying that 20 equals to 20, okay, or say for example 160 equals to 160, right, it doesn't mean that there will be a change. No, there is no change. Here also there is no change. So let me draw it in a fresh piece of paper which will make things clearer for you. So going ahead with the example that we have seen, that when we are trying to equate those two proportionality sign, that 20 is proportional to 10, say for example, or if I take dot 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 and I say 160 is proportional to 80, right? And then when here I am drawing those values, that 20 equals to 2 multiplied by 10, or here when I am saying that 160 would be equal to 2 times 80, right? So what I am doing is that I am introducing this sign, which is a constant, and I am writing the notation as production of glass is equal to a constant K times the output of glass. Now when I'm using this sign, which is these two 2's, right, what is happening is that now when 160 becomes equals to 160, that means that this value doesn't have any proportionality. That means it is not changing further. So now you see the concept has become much more clear. If I go back to our original definition, so in mathematics, the quantities are said to be proportional if they vary in such a way that the quantities is a constant multiple, and equality means the same. So from here you see these are the values which are varying. But when I remove this constant proportionality and introduce a constant, that means they are not at all changing. So going ahead further with this, let us go and understand one more concept. It would be a nice definition to understand. You see, in mathematics, equality is a relationship between two quantities, or more asserting that the quantities have the same value. So here you see I have A equals B. So equality is a relationship between two quantities. Now further you will see here I have written X equals to Y. All right, X and Y denotes the same object. Now just note that here mathematical object is something different, although I am not going into this very definition of what is a mathematical object. It will take another video, but this is what is equality about. It is A equals B. It is the relationship between two quantities. X equals to Y. X and Y denote the same object. Similarly, if you look into this, the identity x plus 1 whole squared, if I further expand to x squared plus 2x plus y, means if x is any number, so this x, if it is any number, then the two expressions have the same value. then the two expressions have the same value. So x and y are the same. So now you see this is same, but what have we found earlier? That in proportionality things are changing. I will show you a further example. See here, a equals to b, right? If a equals to 5, then b equals to any value which is equal to that. Any value which is equal to that. But mind it that when I am saying that a 5 equals to 3 plus 2, it doesn't denote any change. That means there is no this part, right? There is no proportionality change that we put a constant like k or 2 or something like that. So this is what is the concept of equality. Just it is a good concept, it is a good thing which I think you should learn. And from here also we come that that's this equation. So once equality comes into the play, obviously equation comes into play. So equation, the word equation actually is it in late 14C. It means action of making. It is a kind of an action of making. What equal? Equal means, it is a Latin word, it means adequate or equator or equality. So obviously when we are talking of equation, say for example here if I draw a kind of an equation like x plus y equals to 2 or 3x plus 5y equals to 7, that means we are introducing a concept where these two values are equal. So here you see adequate, equator and equality. So the values are more or less the same. Here also these are the values which are the same. But look into what we deduced. If you remember the earlier one, if you see, I will just flip over the page. Here you see these two are equal, but these two, when I am telling these are not equal, there is a certain change. That means 20 to 160, there is a constant multiple of something. That is why it is proportionality. I hope this makes things clear. We will come to the definition of proportionality also, and we will see further what it is. So let me put up a fresh page where things are much more clearer. Here it is. Now you see the definition of equation. Why I am showing equation? Because from equality, because equality means making two things together or something like that. So automatically the concept of equation comes in. A statement that the values of two mathematical expressions are equal, which I denoted by a equal to sign. This is what is equation, or the process of equating one thing with other, right? So here also it is same. So when I say x equals to y or 3x minus 5y equals to 7, something like that. So it means what? It means that we are trying to equate things, but proportionality is not. We will come to that. So the process of equating one thing with another, it is a process of equation. Now what is the definition of proportionality? You look into it. Proportionality is equality between two ratios. Mind it, this word. I mark it in red. Proportionality is equality between two ratios. A by B equals to C by D. A and B are in the same proportion as C and A. A and B are in C proportion as C and A. The term proportionality describes any relation that is always in the same ratio. So here we will involve the concept which we all know from our school days, that what is a ratio. So ratio is basically a quotient of two. So values A, B, it is A is the antecedent which comes at the first, B is the consequent. So if I say, although this is something really funny, but if I say college with 1000 teachers and 50 students, then they will cancel out, it would be 20:1, right? So this is how the definition of proportionality and equality comes. So I hope that things are getting much more clearer. So equation is something where the values are constant. Proportionality is something where there is an equality between two ratios. And that is why this particular example shows like that there is something which is changing with a constant change. But when we are introducing a constant k, that means there is no change. The values are exactly the same. And that is the reason why we put up constant. Okay. So we are almost at the end of our video. I will just pull across something very important for you. Okay, so these are few of the properties which are called the properties of equality. So first one is the reflexive property. If you can see this clearly, I have written that if A, then A equals to 7. So what does that mean? that if it is 6, then A equals to 6. So if it is, so the reflexive property, actually what is the meaning, internal meaning of reflexive property is what is called a reflection. So you are just, kind of watching a mirror, right? You're watching a mirror where you stands, that is for example, your image A equals to A, right? So 3A squared becomes 3A squared equals to 3A squared. So this is called a reflexive property. Reflection, as we mean that we stand and what we see is the same. So that is what is called the term reflexive property. Now you see the second one, which is called symmetric property, which if A equals to B, then B equals to A. So how it will look like, for example, if I give an example, say Qn equals to PR, right? Then as per the symmetric property, PR will be also equal to Qn, right? This is what it is called. Transitive property, let us see an example. Say for example, if I take x equals to 2 and if I take y equals to 2, right, then x would be equal to y. This is called the transitive property. Let us see what is the addition property. Quite clear. Say for example, if I take 9x minus 8 equals to 19, if 9x minus 8 equals to 19, then I can say that 9x would be 19 plus 8 equals to 27, or whatever be the value, equals to 27. This is the addition property. Okay, let us come for the subtraction property. So in subtraction property, what do we get? Say for example, if 3x plus 12, I'm just taking any figure, equals to 14. If 3x plus 12 equals to 14, then I can take that 3x equal to 14 minus 12, that is 2. Right. So what is the division property? We already know. Say for example, from this, if I take 8x equals to 32, then x equal to 32 by 8, which will be 4. These are quite simple, right? And say for example, if I now take what is this multiplication property? Say for example, if I take x by 2 equals to 12, right, then x would equal to 12 multiplied by 2 equal to 24. Okay, there are two more properties which are left. Now we will see what is the substitution property. So in case of a substitution property, if I can take a value, say for example, I take 3x plus y, substitution property, yes, 3x plus y equal to 8. 3x plus y equal to 8. Okay, and here I take y equals to, say for example, 2. Then I can write 3x plus 2 equals to 8, right? We're not solving further. Distributive property, what is the distributive property is telling? Say for example, if I take the value, say 2y plus 2, 2y plus 2 equals to 22, say for example, then what I can do is that I can say 2y plus 4 equals to 44, right? I can multiply this. So let me show another example. So this would be 2y plus 4 equals to 22. Right. So these are few of the examples. Now the concept comes, say for example, you might be wondering that why we are showing those values. Like we have seen those values, the reflexive property values. We have seen symmetric, transitive, addition, subtraction, substitution, distribution. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you might be wondering that why we are showing this. These are equality properties, that is fine. But why we are showing? In advanced mathematics, what you will see is that we need these things in order to make a proof more formal, or we can make a proof more stronger. That what does it mean? That means if I'm going to show a kind of an equation where x equals to y, we need to find out all those properties, and if they satisfy with each other, then we can call that these two equations satisfy the properties of equality. Say for example, if I take let us do this. Say for example, So if I pull up a reason, say for example here, and say I pull up a statement around here. Okay, so for example, the reason is mammal, right? So if a reason is mammal, what is the statement that will prove? So females that secrete milk for feeding the young. So I can tell it that females that secrete milk to feed the young. Right, it is a kind of a logic. So who is a mammal or what is a mammal? If it is a reason, statement would be females that secrete milk to feed the young are called mammals. Right. Say for example, if I take another, say if I write herbivores, say for examples. So the reason would be herbivores. Who are herbivores? Animals that feed on plants. Right. So animals that feed on plants are called herbivores, right? And females that secrete milk to feed the young people are called mammal. So all these reason of reflexive, symmetric, transitive, and all those values or all those reasons, because in case that we want to prove that whether equation is satisfies the values of equality or not, then we will use those, and once the equation satisfied those reasons or those properties, we can call that it is an equation which satisfies equality. Just like mammal, females that secrete milk to feed the young people, these are called mammals. Herbivores. In this way, in logic also, you might find numerous definitions which has got a definite reason, and only which satisfies that are called formally they satisfy the equality statement. So I think that is all for this particular video. I have made things clear. So just one more example which I would just like to show you with a fresh page. Say for example, I come across with this kind of a situation, right, where we are selling, say for example, we are selling shoes. So in case that we show them that $1, it's nasty. So say for example, if I use $1 and I tell them that it would give you one shoe, right? And then I will use $2 and it will give you two shoes. Okay, and then we use $3 which will give you three shoes, and so on. So what I can tell from here is that this dollar is proportional to the number of shoes, right? So this is what is called proportionality. The moment we say that x equals to y, a equals to b, 2x plus 3y equals to 19, whenever we are using this particular value, that means this part of this statement will be equal to this part, and there is no change. Here you see there is a change, but here there is no change. Here also there is no change, right? So that is all for the video. So it was quite an interesting concept, just I thought. So just a quick revision before we end this video. So you have seen this part, that what is exactly an equation, the degree, I'm so sorry, this is from a different page. I'll just quickly show you those properties. Yeah, so in mathematics, equality is a relationship between two quantities, A and B, X and Y, which are denoting the same object. Because they are denoting similarity, so automatically the term equation comes. So the root term is from Latin, which means adequate and equator, or you are equating something with the other. When I show that what is proportionality, you see proportionality is equality between two ratios, and I have explained you what is the concept of a ratio. Also, we have come across this definition, which is in mathematics, two quantities are said to be proportional if they vary in such a way that the quantities is a constant multiple of the other. We have seen examples of this, which I have shown with production and output, that this is varying and this is varying, and this is the reason that we put a constant, because we want to replace this proportional sign with a constant, and this is the value of the constant too. So whenever we are using proportionality or proportion, so we need to understand that there is a change, there is a ratio involved, and there is a certain degree of change. That means that with x, this value y will change. As soon as we introduce the concept of equality, that means there is no change. The value on the left hand side will be equal to the value on the right hand side. So this is a wonderful concept. I think this is quite unique, which I have brought up. Difference between proportionality and equality. I hope you liked it. So I will come up with more concepts, and I'm yet to finish my series in differential equation and tensors. We will come up with this type of concepts more, but for the time being I am starting with this new series, difference between, and I will try to put up certain things which are quite interesting and needs a conceptual understanding. Thank you for watching this video. Please like and subscribe and put up your comments if you need anything more. So stay safe and stay happy and have a nice day. Bye.